This lecture will focus on sketching 2D orthographic views from 3D models and pictorial sketches. One of the important takeaways from this video is an understanding of how to look at a 3D object and quickly see its orthographic views. In previous videos, we have worked the visualization problem from 2D orthographic views to 3D pictorials. In this lecture, you will also learn how to create orthographic sketches of simple mechanical parts or doorstops. You will also learn or have a better understanding of how third-angle orthographic projection is accomplished. So let's begin. Here is a CAD model of a simple part, or what I refer to as a doorstop. In previous videos, we provided instructions on how one creates pictorial sketches. In this video, our focus is on the creation of 2D orthographic sketches while looking at 3D parts and/or images oriented in a pictorial way. Here are two orthographic sketches. The bottom sketch is the front orthographic view. The upper sketch is the top orthographic view. I'm back here with my son, Rob Jensen.
Hey.
Hopefully you remember him from a previous set of videos where we demonstrated the drawing, the sketching of pictorial views.
Yeah, that was a lot of fun. Hope you guys had fun too.
In the next few video sessions that we do, we're going to focus on sketching orthographic views, going from a 3D image to planar 2D front, right, top side views.
Cool.
Does that make sense?
Yeah, so we're going the opposite direction.
We're going the opposite direction. So hopefully viewers will remember this little object from last time.
I remember it.
So what we're going to do is we're going to try and figure out how to make orthographic views from a 3D object.
Okay.
So one of the ways to do that is to kind of draw planes, sketch planes, and then project lines that come off of that onto this front plane as dots.
Okay.
And then connect the dots. And so I'm going to let you sketch a front view. So let's assume that we're going to use that direction as our front view and kind of sketch a plane that we can project onto.
So it's going to float out. Is that what you're meaning?
Yep, some distance in front of that.
And then this is going to go straight up.
Yep.
And then straight across.
Yep.
You want it the same size?
Well, it can be a little larger.
A little bigger.
But it doesn't matter.
So it's the same on this side, or on the sides, but a little taller.
Yep.
Okay.
And so maybe darken that in with a Sharpie or something. Notice how he's drawing it towards the core of his body?
Yeah.
And he's keeping his eye kind of focused on the point that he wants to end at.
And drag it.
And drag it.
Oh, got a little wobbly.
So that represents this plane that we're going to call the front view, or the front orthographic view.
Okay.
Now what you do is you come along and you basically project intersection points. And so we can just project this line out to where it intersects and put a dot there.
Okay.
We can do that to this line.
Wow, that's gotta use your imagination, huh?
Right, but you can use approximately the same depth that you're off. Yeah, there you go.
We could
do
this.
Do that one.
Do the top one?
Do the top one.
Because that'll help me get straight down.
And then it's straight down from that one.
From this one.
Yep.
There we go.
And we can do this top line.
Okay.
And you've kind of already done the back line. And we only need to do this inside bottom line, which is straight down
Straight
from that.
down from there.
So now take your Sharpie and connect the dots.
Cool.
Okay.
How about
that? Great. That represents the front view, the front orthographic view. We're not seeing a planar. We're going to do that in just a second. Okay. Let's do the exact same thing for the right side view. And so now our viewing direction is like that.
Okay, cool. How about that?
That looks good. And now what we want to do is project this point, and these top ones are already been projected.
Yeah.
Out. But what about this point back here? Or the point that corresponds to that back here someplace?
Can't see
do we
it.
want to project that? We could project this line out here, but if we did, we would need to make the line dashed, showing that it's a hidden line.
Ah, okay.
And so let's go ahead and kind of project this out and that out. It's a little difficult, but what you can do is you can actually take this measurement and just bring that measurement out here. And so because you don't have a perfect line.
Yeah, to come off of.
Yep.
So there.
And you can do the same back there.
That'd be the same dimension, right?
Yep.
And I didn't make that plane bigger like I did over here. So this is the top edge, right?
All right.
And then this, how would you do this? You could measure that?
You could project this line. Just follow that line straight out.
Okay.
And you don't have much of a line, but it's going to be the same height.
Same right here?
Yep.
Maybe?
Yep. And that becomes a dash. So let's darken it in with your Sharpie, and let's make this line a dash line.
Okay.
Great.
Is that it?
That is it. The only other view, so this is our right side orthographic view. This is our front orthographic view. We now need to be looking down, and we need to create the top orthographic view.
Okay.
We just need to project this line up and find a point, and this line up and find a point, and this line up and find a point. And we don't have very good lines to project up, but we have measurements that we can actually pull off.
So if we do that, there's that point, straight up, there's that point.
Yep.
This one.
And we can do,
Okay.
And we can do this line easily.
Oh, yeah.
And now if we take this measurement and apply it back here, we'll end up with roughly,
And you could do just a straight up and down line from that point too, right?
Yep. And the same with that.
If you don't have a ruler, that might be easier.
Okay.
Cool.
Start darkening things in.
Okay. Is that it?
Yep, except for the circle.
Oh, yeah. So that would just be the same circle, right?
Yep.
Kind of.
Pretty good. Now, why doesn't it look like a circle?
It's still in perspective.
It's
or
still
in 3D.
So now what orthographic views do is they take these things and they open them up.
Okay.
So they open them up and lay them flat, and what you're going to end up with is you would end up with, say, views like this. This would be the front view, the right side, the top view. This is a front view, a right side view, and a top view.
Cool.
A front, right side, and top. And so we just need to open these up and lay them flat.
Awesome.
And so to do that, I brought some graph paper, and we can very quickly come up with our 3 orthographic views. Now, like last time, what we did is we actually came in here and decided kind of lengths. And so we're going to decide that the overall length of this thing is 11.
Okay.
And the depth of this thing, we're going to put that at, let's say, 6. And let's say the height is 5.
Okay.
And let's decide that this up here is, let's say, this length is 3. This depth is 2. This is 3, and that's 1.
Okay.
And this circle is centered.
Awesome.
So let's see if we can do that.
Okay.
Now, maybe what we want to do is actually turn them this way.
That's
so
what I was
we've got a
thinking.
little bit more to play with.
Since we got 11 for the front view.
Yeah.
Okay.
So just start doing it, and we'll see what we end up with. Oh, we forgot one measurement. So let's call this one 2.
Cool.
Then you decide how far away you want. Maybe you want 3 boxes or 4 boxes away. I'm going to do 4.
To do this, to start your side
to do
view?
the side view.
Okay.
So I'm going to go 4 over, and then I do 2, 4, 6.
6.
Wide.
And we said 5 up. And it should line up with the other one.
Should line
right?
up with that.
And it's just going to be a box with lines going across.
With lines going across. And now we do the top view. And so typically what you do is if you offset this by some number of cubes,
You do the same?
you do the same up here. And so you start off and you know that this is going to be
Oh, yeah.
that long.
You just go all the way.
And then you count 2, 4, 6. So graph paper really helps mechanical engineers quickly come up with their sketches
Yeah.
for orthographic views.
And you can just project these without even
you can,
counting,
without
right?
even counting. Now, if we wanted to, we could take our Sharpie to darken these things in because there's so many lines on the paper. It's pretty easy if you can if you can visualize the planes that you project to off of this 3D image, and you're able to mentally unfold them, you can very easily lay them out very quickly, very easily lay them out on graph paper.
Yeah, that
as
wasn't
a
too
front, right, and top
orthographic
view.
Yeah, that was a lot of fun. And it was pretty easy, especially when you have the graph paper. You can easily kind of measure things out. And that was fun.
Great. I hope you enjoyed that demonstration of how to visualize and project surfaces onto front, right, and top orthographic viewing planes. The next demonstration will show another approach of going from 3D objects and pictorial images to 2D orthographic views. Here we have the engineering graphics book by Giesecke and a bunch of other people. Okay.
Cool.
And in these books, you can find all kinds of examples. You can find examples of objects, and these are just more doorstop objects like we talked before.
Yeah.
And these objects are illustrated in 3D or pictorial kind of view. And so we have a couple of different sheets so we can kind of work off of.
Yeah, those look fun.
This one I think is a little easier because it's got lots of straight lines and pretty basic arcs. This has lots of curvy things going all over the place. So in the Giesecke book, we have these kind of images. If you have been using or you purchased the Bertolini book, the technical graphics book has some of the 3D, but they also have lots of the kind of orthographic where they expect you to actually draw the pictorial view.
Yeah. Okay.
And so you can find lots of examples going both directions. So what we want to do is we want to take these examples from Giesecke,
Okay.
and we're going to color them We're going to use the red as
right.
the front view.
You want me to do it, or are you going to do it?
I'm going to let you do it.
All right.
We're
Okay,
going to use red as the front view. And so let's pick this number 11.
Okay.
And let's color everything that we would see from the front view.
All right. Okay, so I'm guessing we're going to see this side. And the front view is going this direction,
Yeah,
right?
so put that arrow in there.
Okay.
Now this is another technique. Instead of projecting it out to the plane like
Yeah.
we did in the last video clip, we're going to actually just color it.
This seems a little easier, right? So we
Yep.
don't have to draw anything. We can just imagine it.
Yep.
So is that right?
That's
that
correct.
little corner, but it's not going to be this one.
It's not going to be that one.
Cool.
Okay. We're going to use yellow as the, what do you see from the right side?
The right side, so that's this direction?
That's that direction. And yellow may not show up very well.
Yeah, might not as well.
So what I want you to do is fill in this little face
Okay.
and fill in this little face.
Ooh.
And I want you to basically crosshatch just with lines, a bunch of lines, that thing. Okay, and up here.
I have a feeling I know why.
Now that's exactly what you're going to see from the right side
Right
view. This plane, the one that we just kind of put lines across, ends up being kind of foreshortened and projected out here to the right side view.
Yeah.
And we're going to use blue to color the top.
Okay.
We just fill that in nice and pretty. And what else is the top? Well, the top is also by
It's that
this
yellow.
and so just put a few lines of blue going across that thing because we'll also see that.
There we go.
Nice.
Try to make it pretty.
So, using just normal white paper, let's see if we can just have you sketch
Okay.
the 3 views quickly
Oh, okay.
of that object as orthographic.
Okay. Whoa.
Cool.
That was fun.
Cool.
That's really cool. It's almost like a puzzle.
It is.
Trying to
It
figure
is,
that
it
out.
is. It is. But do you see how if you can visualize what
Yeah.
surfaces get projected to the front plane, what surfaces get projected to the right side plane, what surfaces get projected to the top,
Yeah.
then you can very easily go over and use that mental image to actually convey it and put it on a piece of paper.
Yeah, the colors helped me isolate what was going to be in this view. And so red was only in this view, blue was only in this view, and yellow was only here. So it did. This exercise of coloring does help you kind of isolate those different views.
So now we're going to go to a little more complex sheet.
Oh. We're going to use the colors again?
We're going to do the colors again.
Okay.
Okay. And so which one do we want to pick?
Do I have to draw it after?
You have to draw it after. Let's pick this one.
Okay.
Does that look?
Yeah,
I think that's number 17.
That looks most complicated. Thank you.
So let's take that and start again with
Okay.
what we're calling the front view.
All right.
Okay.
So we use red for the front, didn't
Yep.
we? Okay. All right. So I'm guessing it's going to be here. Then here.
Yep.
And here is going to go all the way to the middle point of that arc, right?
Right.
Oh, and I probably should have used dash lines or
Well, we'll just
Alternated.
put the
we'll color over it.
color over it.
Okay.
Okay.
All right.
So now we're going to the front, or excuse me, the right
Side view?
side
Okay.
view.
So this
That yellow is not going to show up on top of the red very good, is it?
probably not.
Because it comes all the way to this edge right there.
It's going to be here. Is that a step out, I think?
Yeah.
And it would be this too, but this is going to be behind it.
So that's completely hidden
Yeah.
by it. And it goes all the way and wraps back around that side.
So this little side.
Yep.
And then it would come all the way over here too. Right?
Yep.
Okay.
Correct. Okay.
All right.
And the top.
This way.
Yep.
It's going to be this piece.
Yep.
Here.
Yep. The inside, yeah.
Mm-hmm. Top of this piece. And this back piece, right?
Yep. Correct. Graph paper or regular paper?
Graph paper.
Graph paper it is.
Yeah. It's a lot easier with graph paper.
There you go.
All right, you're going to do it with me, right?
No, no. I was going to just watch.
All right.
Now, maybe one thing that we should talk about before you start drawing
Okay.
is there's these little chicken feet or hash marks all
Yeah.
the way around here. There's some right there.
Does that mean there's a radius?
Yeah, so you see this kind of stuff over and over again. So here there's little edge marks and they're trying to show. So there's a really small radius that blends from a flat surface to a flat surface. And so it's a little fillet. And this is a much larger radius going around the front. But from the blue surface to the red surface is a little fillet that goes around there.
Cool. Okay.
Let's pick dimensions. So let's say overall this thing is, 14.
Okay.
It's 14 from this back edge to this front edge. And let's say that it's 6 tall.
Okay.
And let's say it's only 5 wide.
Okay.
And we need to decide on some other thicknesses. So this front thickness right to there, let's make that 1. And notice this center part is thicker, so let's make that 2 thick,
Okay.
2 high.
All right.
And then let's make these each 1 thick.
Oh, okay.
Does that make sense?
Yep.
So we've got to decide some other thicknesses, right?
Okay.
So what is this center gap going to be? Let's make the center gap 6. That's maybe bigger than it should be. In fact, that's way bigger than it should be. Let's make that center gap 4.
Okay. So we got to do some math to subtract
So
some
it's
stuff
right.
out. Huh?
So this is 4, 1 and 1. That's 6. So 6 from that is leaving you with 8. So each of these sides
It's 4.
is going to be 4.
Okay. That makes it a little easier. So we're going to go over like this.
Now these ends are a little tricky because notice that there is this large radius at the end, and it comes and it's tapered.
Yeah. So it starts a little in, right? That's why it starts a little in, and then the apex is right here in the center.
Actually, I wouldn't say that it just blends straight into that surface.
Okay.
And so in reality, it comes from this corner point.
Okay.
And maybe what we do is assume that it's going to taper to an arc.
Here.
Yeah.
That it?
So let's darken these things up.
Okay. There we go.
Great. If we look at examples from Bertolini and compare them to your sketches, we see that while these were done maybe with a straight edge or a ruler or something like that, you can use freehand drawing techniques on top of grid paper and get very close to what you would have if you took more time and used a straight edge.
Yeah, that's awesome. It's a quick way to get that idea kind of visualized.
And so what we want the viewers to do is we want them to spend time going from 2D
Orthographic
to 3D sketches.
Cool.
We also want the viewers to go from 3D sketches to 2D orthographic.
Go both.
Being able to go both directions is vitally important to engineers and designers.
Awesome.
And the more they practice, the better they're going to be at doing this. Thanks again for your help. It was great.
Yeah, no problem. It was a lot of fun.
Well, we enjoyed this very much, and hopefully you did also. So remember, practice going from 3D pictorial to 2D orthographic views. Also, practice from going from 2D orthographic views to 3D pictorial views. It's going to be a great boost to your engineering or design career. As I have said at the end of other lectures, the only way to improve your sketching skill and your ability to visually move between 3D and 2D scenes is to practice, practice, and practice some more. I recommend that you do as a minimum one set of orthographic sketches of an object or pictorial image of a doorstop each day for the next 16 days. If you choose one of these rectangular objects, you should sketch their front, right, and top orthographic views. If you choose a cylindrical object or image, you should sketch their side and end orthographic views. Let's review what you should now be able to discuss. You should be able to look at an object or its pictorial image and describe how to identify what surfaces are projected to the front, right, and top orthographic planes. You should understand how to do freehand orthographic sketching of 3D objects, including the use of graph paper. You should understand how third-angle orthographic projection is used in the placement of standard front, right, and top orthographic views.